You've seen it happen, right? The exact same AI model gives you a brilliant, flawless analysis, and then moments later gives your colleague a complete fabrication. We call it a hallucination. We treat it like a bug, a lie, or some kind of failure in the machine's brain. But what if that's the wrong way to look at it entirely? What if the core idea is much simpler? AI isn't lying to you, it's guessing.
And this right here is the signal we need to tune into. The model isn't failing to understand you, it's acting like a mirror, reflecting the density of your instructions right back at you. If your instructions are vague, guess what? You get a vague output. If your instructions are packed with detail, high density, you get a high-density output. This is the fundamental mechanic we're going to unpack.
Okay, so that begs the question, right? If it's just a mirror, why does that reflection sometimes invent facts, cite sources that don't exist, or just make stuff up that is demonstrably false? Well, to answer that, we have to look past the chat box, go under the hood, and see how the system actually works.
To really get this, we have to completely reframe the problem. This isn't about deception. This is about statistics. We're talking to a system that was built from the ground up to make statistical guesses, and the quality of those guesses is a direct function of the information we feed it.
This quote really nails it. A hallucination, as we call it, isn't some malicious act or a glitch in the matrix. It's just the mathematical result of the model having way too many plausible options to choose from. It's what happens when the statistical distribution is just too wide.
So what is distribution spread? Well, think about it. A language model's only real job is to predict the next most likely word. When your prompt is wide open and has no constraints, it creates this huge, massive field of possible next words. Now, the path the model takes through that field can sound perfectly confident and fluent, but because that path isn't tightly defined by you, it's way more likely to just wander off into territory that looks real but is completely invented.
And this is where we see the pattern emerge, because it turns out the person fueling this ambiguity engine is us, the user. We, often without even realizing it, create the very conditions that allow these statistical guesses to fly off the rails.
This shows the dynamic perfectly. On the left, you've got an open prompt, something like write about economic policy. This creates high entropy, a massive, chaotic field of possibilities. The model has to guess what you mean. But on the right, you have a constrained prompt. Summarize the key fiscal policies enacted in Germany during Q4 2023. Suddenly, the entropy is low. That wide-open field becomes a narrow, focused corridor. There's just way less room for it to invent things.
And we create these high-entropy situations with what you could call semantic gaps. Anytime we leave a variable undefined, we're creating a gap. You don't specify a date, the model will pick one that sounds plausible. You don't name the people or companies involved, it'll grab the most statistically common ones. Vague scope, ambiguous formats, they're all just open invitations for the model to fill in the blanks with its best guess. And that guess is often just a fluent, confident-sounding approximation of reality.
So, if the problem is a wide-open, unconstrained field, the solution is pretty clear, isn't it? We have to understand the system for constraining it. This is exactly how expert operators get such consistent, reliable results. They are masters of controlling the model's guessing space. The tools they use for this are what we can call entropy dampeners. And look, these aren't some complex secret hacks. They're just specific, clear inputs that act like filters on the probability. Every single constraint you add, a name, a date, a specific format, compresses the model's search space. It forces it down a narrower and much more accurate path. Let's just watch this in action. You start with an unconstrained state, a really wide-open request. Then, bam, you apply a time frame, say, in the 21st century. You can almost feel that field of possibilities just shrink. Then you define a format in a bulleted list. The field narrows even more. And finally, you specify the exact entities. Each step systematically squeezes the room for error, guiding the model away from a wild guess and toward a targeted, specific result.
And this brings us to a really crucial point. Getting reliable results from AI has almost nothing to do with how intelligent the user is. It has everything to do with the density of your constraints. It's a structural relationship. High-density input leads to high-quality output. It's as simple as that.
So what happens when we don't understand this system? What's the real cost of relying on these unchecked fabrications? Well, it's very real and it's hitting professionals in just about every field you can imagine.
I mean, think about it.
It's the professional who wastes hours correcting an output that came from a vague prompt. It's the developer who blames the model for a bug when their own instruction was ambiguous. It's the creator who is drowning in endless revisions of generic copy, or the analyst who builds a whole strategy on a synthesis that sounded confident but was actually completely hollow. The cost is real. It's wasted time, it's eroded trust, and it leads to some really bad decisions.
We tend to think of a bad AI output as this sudden, random failure, but it's not. A bad output is the final, logical destination of a journey of small, accumulated misalignments. Every little semantic gap, every vague request, it all adds up, like being 1 degree off on a compass. At first, it's no big deal, but over time, that trajectory inevitably diverges from reality.
So this brings us to the edge, the mindset that separates the inconsistent users from the expert operators. And the edge isn't found in some secret list of prompts. It's found in a mental shift, from generating answers to auditing probabilities.
You really have two different mindsets here. On the one hand, you have single-pass generation. This is where you treat the model like a storyteller or an oracle. You just ask it for a finished answer. But the expert mindset is iterative verification. Here, the first output is never the answer. It's a draft, and the model is repositioned as a tool to help you check, validate, and refine that draft. It stops being a storyteller and becomes a checker.
And this table just breaks down the difference in what people actually do. The novice user prompts to get an answer, and if it sounds good, if it's fluent, they accept it. Why? Because their goal is a fast answer. The expert prompts to generate a draft, and they immediately start checking that draft. They look for contradictions, they ask for sources, they test its logic. Their goal isn't speed, their goal is a verified result. So to wrap all this up, the key to mastering this whole interaction is to stop blaming the tool and start examining our own process. And we can do that by turning the lens inward with a few sharp, self-reflecting questions. First one, the next time you get a flawed output, just stop. Before you get frustrated or edit the prompt, ask yourself, where in my original instruction did I leave room for interpretation? Which word was vague? What detail was missing? At what exact point did I force the model to guess?
The second question is about your workflow. Think back. Did you just take that first fluent response and run with it? Or did you explicitly tell the model to check its own work? Did you ask it to find sources, to point out contradictions, to tell you where it was least confident? What was your verification step? Or do you even have one? And finally, this is the question that really encapsulates everything. The next time you see a fabricated response, ask yourself this: is the problem really the model's intelligence, or is it the gap that I left in my own instructions? Because shifting your perspective to focus on that gap, well, that's the first real step to truly commanding this technology.